Alright, so we're going to finish up vectors with vector equations. They are connected to everything that we've done, even including parametrics. So I've got up here boxed off the general format that we're going to use. That's essentially our starting point. So we're going to take a particle going from point A to B. We've got the given location and the time it took to go there. And we're going to find all of this information. So let's get it back into focus here. There we go. So the first thing that we're going to find is velocity, which is basically the component vector is how we start. So 5 minus 2 gives me 3, 10 minus 1 gives me 9. So that's the component vector. But velocity is just that speed for 1 second. So the particle covered this amount of, we'll say, ground in 3 seconds. So if we want to know how much it can cover in 1 second, we're going to divide it by 3. If it had gone from t equals 0 to t equals 8, we would divide by 8. So that's going to give me 1, 3. That's the velocity of this particle. That's also A and B. Think of it like our component vector. The speed is just the magnitude of this vector. It's that hypotenuse. Think of it that way. So a squared plus b squared, the speed is just radical 10. You could do a decimal if you would prefer. And then vector equation is just plugging things in. So x and y, just like every equation we've worked with, circles, lines, parabolas, ellipse, hyperbolas, x and y stay x and y, x naught and y naught. So if you're not familiar with that notation, it's called naught. It's little subscript zeros. That just means your starting point. So we started at point A, which was 2, 1, plus some t, some time, some velocity, times my velocity. So my velocity over time. Basically, this is how much, this is the velocity, which is the speed at 1 second. So now if I want to know where it's at after 7 seconds, which is part D, I'm going to substitute 7 in for t, and that's going to tell me where this particle is going to be at. So we've got 2, 1 plus 7, and you could go ahead and distribute that 7 through, so 7 and 21, 2, 1, which when we combine these, we can combine A terms, so that gives me 9, and then we can combine the B terms, which gives me 21. So the location, whoops, x comma y, after 7 seconds is at 9:22, and it should be past the 5:10. If we were to draw this out, it should definitely fall further along that line. Then we're going to create a parametric equation, which is very easy. You go from your vector equation, and the parametrics, remember, are just a pair of equations. So we have an x equals and a y equals, and you literally just pull your x values out. So here the x was 2 plus 1t, and then for the y's we had 1 and 3. So 1 plus 3t, and that's my vector equation. That's describing horizontal movement and vertical movement in relation to the time. So instead of it being horizontal is dictating the vertical, time is dictating both. And then the last part, this is just a made up line, 3x plus 4y equals 78, and we want to know when the particle will cross that line. Well, I know what x equals, and I know what y equals, so we're going to substitute those in. So we've got 3, and instead of x, I'm going to write 2 plus t, and then I've got 4, and instead of y, I'm going to write 1 plus 3t, and that's equal to 78. This is getting crammed in here. 6 plus 3t, this is just straight up algebra, plus 12t is equal to 78. So I've got 15t, and it's equal to, let's see here, what would that be? 78 minus 10 gives me 68. So 68 divided by 15 is going to give me 4.5 approximately. So 4.5 seconds is how long it's going to take to cross this line. Then the last step is, where will it cross that line? I've got to find the exact coordinates. Well, I know what t is, so plug that back in. So we can find the x value, 4.5, which equals 6.5, and then I have y equals 1 plus 3t, and 3 times 4.5 plus 1 gives me 14.5. So the where is just going to be as an ordered pair, 6.5, 14.5. So lots going on with this problem, but it all stems from the vector equation. If you don't have that down, and I would recommend circling it or putting it somewhere off to the side, because you're going to refer back to that And then you just figure out, well, I'm given t, I'm given a time, so plug it in. Here I want to know where, so I need to plug that t in to get the coordinates. You just have to understand what you're looking for and where you plug it in.